Okay, so let's go ahead and talk about how is this completing the square help us put something into something that we can actually see the vertex. Because right here, in order for me, I can find the y-intercept. I could factor it and I could find the x-intercepts. But I actually, looking at this form, I don't see the vertex, do I? I would have to graph it. So if we put it in that x squared form, that vertex form, do you remember what the vertex form was? F of x equals a times x minus h squared plus k. You might memorize it. Okay, that's what we call the vertex form. If we complete the square, and now we're not solving, we're just getting it into a different form. So I'm taking the f of x equals x squared plus 2x. I'm going to set the 8 off to the side. Because what I want is I want to get a perfect square trinomial there, right? The same thing we saw before. Now, I know I'm going to be adding something, but I don't want to put another thing on the other side. So if I add and subtract the same amount here and here, then I will be able to get it into vertex form. And I will also be adding 0. If I add and subtract the same number. So what number would make this a perfect square trinomial? 1. How did you get that? Half of 2 squared. So we have 1 here, and it just so happens by coincidence that's x plus 1 squared. And then you're going to be subtracting 1. So negative 8 minus 1 is negative 9, right? Who can tell me what the vertex is? Negative 1, negative 9. You see how we got that? What's the domain then? And I didn't read the directions, I just psychically know what they are. So you should read the directions in the future. The domain of any parabola is going to be? Yep. And what's the range? Yeah, because this opens upward. So wait a second. If this one opens, how do you know it's opening upward? If it opens upward, here's the smallest point, right? Negative 9 to infinity, because the y coordinate, there's negative 1, negative 9 is what the parabola is going to look like, okay? So there's lots of more examples for you to try. I'm going to ask you to try example 8, and then we'll share out on that. But because we're running short on time, I'm going to go ahead and scroll up so that you can see an example that doesn't start with 1. This gets a little bit more complicated when you have your leading coefficient is a number other than 1. So we want to put this into vertex form by completing the square. So what we're going to do is we're going to write it, f of x equals 3x squared minus 12x, and then leave the plus 11 off to the side. So that's the first step. Take that c and put it off to the side. Now we know we're going to be adding something and then subtracting something. But the problem is right now I have this 3 involved. So my second step is I want to get the 3 out of there. Could I factor it out? If I factor out the 3, I get the 3 out front, and I get x squared minus 4x, and I'm going to add something here, plus 11, and minus that same thing. So whatever I add has to also get subtracted in order for it to balance out to 0. So that I didn't change the value, I'm adding and subtracting the same amount, right? What is going to complete the square there? 4, because you take half of 4 and you square that. So half of 4 is 2. Oops, not the x. 2, right? Squared. So this is 4. But now here's the thing. If I were to distribute the 3 back in, wouldn't I go 3 times 4? Yeah, 3 times 4 is 12. I'm actually adding 12 here. So I have to subtract 12 in order to balance that out. Because of the 3 out front, since I factored out the 3, notice that if I were to distribute the 3 back in, I'm really adding 12. So I'm subtracting 12. So this equals 3 comes down. You have this in factored form. And then what do we have on the outside? Yeah, minus 1. So what's the vertex? 2, negative 1. And what's the domain? Negative infinity to positive infinity. What's the range? It's opening upward or downward? Upward, because A is positive. The range is going to be the smallest y value, which is negative 1 to infinity, because the vertex is at the bottom. It's a minimum point. Okay, so that's completing the square when you have a leading coefficient that is not 1. All right, any other questions about that?